Hi everybody, welcome to another Chats with Children. I hope you're all safe and well. It's a lovely sunny day here in Surrey on a Friday, and I'm delighted to be joined by Gary Kruppa, who is VP for Proteomics Life Science Mass Spectrometry at Bruker Daltonics, who's in sunny Prague, I can tell. It looks sunny anyway from that window, and we're going to be talking about proteomics. Hi Gary, how are you?
Just looking out the window, so it's partly cloudy. I can see some dark clouds on the horizon actually here, but I have the lights on in the apartment these days.
So the wonder of technology. It looks
getting
sunny.
to be fall, but anyway, I'm doing well regardless, and happy to be chatting with you again, Riz.
Fantastic. Yeah. Well, this is, as you just mentioned, the second Chats with Children we're doing together to talk about proteomics. And it's part of an ongoing series we're doing with Bruker, actually talking about the issues around challenges around proteomics. So it's great to see you. And obviously, we did have a conversation about 4 weeks ago now. So if anybody wants to check that out, there will be a link to the original conversation with Gary on this post as well. So Gary, I know you did this last time as well, but there may be people who are watching for the first time. So can you just give everybody a quick overview of Bruker Daltonics and your role within that, if you don't mind?
Yeah, so Bruker Daltonics is the mass spectrometry division of Bruker. The division also includes the infrared optics company as well. So it's not just mass spectrometry, but it's called the CALID division. And within the mass spectrometry part of that division, there's actually two sections. There's molecular and diagnostics, which focuses on clinical diagnostics. And then there's the life sciences mass spectrometry part, which I'm part of, and I am the vice president for proteomics within life sciences mass spectrometry.
Fantastic. So let's talk about HUPO virtual, because I know that's coming up. And what's your Bruker's focus going to be at the show this year?
So we're not introducing any complete new instruments, but we're introducing an exciting new accessory, the PASER Box 1.0 for fast data processing and run and done and real-time MS. And we've also got a lot of news on new workflows and method developments, specifically news on DiaPassive and PRM-passive developments and updates. High sensitivity methods for very low sample amounts, and there are new cross-linking reagents and methods that we'll be talking about.
Right. Well, actually, you mentioned PASSA 1.0 and run and done, because I actually did an interview only recently with your colleague Chris Adams about that, which is very interesting.
Yeah, and for that reason, I don't want to spend too much time on that here. We'll include a link, I think, to Chris's talk here, and people can listen to that. But I think you know from your previous chats with me and with Chris that the timsTOF Pro is a very high-speed instrument that can really generate MSMS data for identifying peptides at extremely high rates. So the IP2 search engine, which can be GPU-based that Chris talked about, can perform IDs in milliseconds, is really a perfect match for the timsTOF Pro, allowing the results to be processed in real time so that when the run is done, you've got your results waiting for you. And that's what we call run and done. And I think Chris did a good job of discussing the other benefits of PASER and the IP2 data analysis platform that are available now and things that we're going to be developing. We're also super excited to have Robin Park, formerly of the Scripps Research Institute, working with Bruker. He used to work with Professor John Yates at Scripps, and he'll continue to do that in his role at Bruker. As sure. We're also super excited to have a really close collaboration with him. And in fact, they'll both be presenting at Bruker. John has a talk in the HUPO program at the Bruker sponsored seminar. October 20th at 15:15, and Robin has a talk at our post-HUPO proteomics users meeting where he'll talk about PASER 1.0 and the IP2 platform, and that's taking place on Friday the 23rd of October. And we'll include links here on that as well.
Yeah, fantastic. Well, yeah, as you say, we'll add those links in to this post with the video above it so people can check those links out and register for those particular sessions. And also, as you quite rightly said, the interview I've just done with Chris, that link is going to be above the video as well. So you can find out more about PASER in that particular video if you want to know more. So last time when we met, we discussed DiaPassive. Is there anything new there? And also, what is PRM passive?
Yeah, so I'll address the PRM passive question in a second. Let's talk about, because DiaPassive, I wouldn't say that's incredibly new. We've been talking about that for a couple of years, but it's really ready for prime time now. We recently released a new version of our acquisition software that controls the instrument. We call that TIMS Control 1.0. And that's got a great new user-friendly and intuitive interface for setting up DiaPassive experiments. And I would say that DiaPassive is now being really widely adopted among our timsTOF Pro customers. So we expect to see many new applications driven by our customers now, not by our internal R&D. And that's also well supported by the ecosystem of software that's supporting the timsTOF Pro, not just for DiaPassive, but also now for DiaPassive. So data processing for DiaPassive is now available from software such as Peaks from Bioinformatics Solutions Inc., Skyline from Spectronaut, Spectronaut from Biognosys. Skyline is from Mike Macasa's group at the University of Washington, of course. And Jürgen Cox will soon release a version of MaxQuant that will also be able to process DiaPassive. So basically, all the most popular software used by the community will support DiaPassive. And I'd say that, we'll again show, we have some posters and other information about DiaPassive at the conference. I think it's really unique in its ability to generate close to complete proteome coverage for cell culture with close to 9,000 proteins identified in a single 90-minute gradient against libraries that contain around 10,000 proteins for cell culture. Alternatively, if you have a lot of samples to run, you might want to shorten your gradient to 30 or 60 minutes, and you can still get very high protein numbers with very good data completeness and get through your sample cohort in shorter times.
Fantastic.
Now, for DiaPassive, you get the best results if you generate a library from the sample you're going to study. So it's best if you're going to be running a lot of similar samples, like plasma for a large number of patients, or cultures of the same cell type under many different conditions. DiaPassive's non-targeted, but it gives you very good data completeness since you fragment and try to match just about everything in the sample against the library every run. But targeted methods still give you the ultimate in data completeness. And PRM-Passive is one of these targeted methods. And what I mean by a targeted method is you decide before you start the experiment what you want to look at, and you create a target list. And so they give you the best completeness because if your target of interest is there, you're going to target it, you're going to fragment it, identify it, and quantitate it. So no missing values at all with targeted experiments. PRM-Passive now, and previously you targeted things based on their known retention time and mass. Right. But now we add in the mobility dimension using the timsTOF Pro. So we target based on mobility, mass, and retention time. And the timsTOF Pro with Passive also adds in the additional speed of the timsTOF Pro and sensitivity. So, I would say state of the art before PRM-Passive was being able to target 100 targets in a 30-minute run on a triple quad, let's say. But we now routinely do well over 200 targets in a 25-minute run. And we have collaborators looking at as many as 500 or more targets in a 30-minute run. So PRM-Passive is still relatively new. We've released it to the community with TIMS Control 1.0. We talked about it at ASMS, but it's just getting out to the community now, and it's super exciting. And I think we'll see a lot of important developments in the coming months. Gunnar Dittmar from the Luxembourg Institute of Health is going to be the other speaker at our Bruker-sponsored seminar together with John Yates at HUPO. And another aspect of PRM-Passive is that we can tie it into our real-time MS engine and make adjustments to the targeting in real time to account for shifts in retention time and to maximize the number of targets we hit. And Jared Mardo of Harvard and the Dana-Farber Cancer Institute is going to be talking about that at our post-HUPO users meeting. It's called PRM-Passive Live. And that's another super exciting topic. And Jared gives a great talk on that.
Fantastic. Well, you mentioned also that you're going to be talking about cross-linking mass spectrometry. So what is that? How is it used? And what are the latest developments there?
Well, the main development in cross-linking mass spectrometry is some new cross-linkers that we have. But to give you a little bit of background, cross-linking MS uses molecules that have a sort of a flexible spacer chain with a reactive group at each end. And they generally, the most common forms react with lysine side chains. And so one side will attach to the protein, and then the other side will attach to another part of the same protein or another protein. And then you do your digest and you get your usual tryptic or enzymatic peptides, but you'll also get some that are stuck together, peptides that are stuck together by these crosslinks. And if you can identify the peptides that are stuck together and the amino acid side chains that reacted, you can say, oh, well, those two side chains in the original structure of the protein had to be close enough together to get cross-linked. And so that gives you some distance constraints, some ideas about what parts of the protein are close to each other, or what parts of different proteins that are interacting are close to each other, and gives you some idea about the structure of a protein or the complex. And it's commonly used to see what kinds of proteins are interacting, as well as to study the structure of the individual proteins that may be difficult to study by other methods. Now, one issue with that is, in addition to these cross-link peptides, you get lots of other peptides that you're not so interested in, and you have to find the cross-links. And Professor Albert Heck and Richard Shelton at the University of Utrecht have recently developed cross-linkers that have a phosphonate group in the middle of this cross-linker arm, where they don't interfere with the cross-linking reagent, but then you can use metal affinity beads to pull those cross-links down. So you can essentially purify the cross-link species from this big background and find them easier. And so we're making that crosslinker available as a product soon. We'll announce that at HUPO. And the timsTOF Pro has some unique advantages for being able to separate and identify these crosslink species based on the ion mobility, but also the speed of the timsTOF Pro lets you find more of these. So the ion mobility lets you separate them, and then the speed lets you find more crosslinks faster. And it's not just the group of Heck and Scheltema that we're working with from University of Utrecht, but we also have new collaborations with the groups of Andrea Sins at University of Halle and Peter Novak right here in Prague at Charles University, who are important key groups working in the cross-linking field. And so we're very excited about the applications of the timsTOF Pro in the field of cross-linking mass spectrometry and generally the field of structural biology as studied by mass spectrometry in general.
Thanks. Well, thanks for that. That sounds very exciting developments actually there. So let's talk about the issue of high sensitivity. So I've been hearing a lot about single cell proteomics. Why is that important? And are your sensitivity developments sufficient for that?
Well, single cell proteomics, if you could do it, would be really important because there's a lot of excitement about single cell genomics methods, studying the translational mRNA or mRNA in a cell. And the problem is the RNA doesn't tell the whole story. Even if you have a lot of RNA, it doesn't mean a lot of the protein is being expressed, unfortunately. There's example after example where the amount of protein that is expressed ultimately isn't reflected of the relative amount of RNA for that protein present in the cell. There are other mechanisms that regulate the amount of protein expressed. And so if you could measure the amount of protein there at the single cell level, you could really help understand the biology of cellular diversity. And that's important both for understanding how cells differentiate from each other at different stages in their life cycles and what changes as a function of what they're doing, but also in cancer, obviously, that precancerous and cancerous cells, how is their proteome and biology changing? So single cell proteomics would really help you understand all that. And progress is definitely being made by a number of groups, but in particular, the group of Professor Matthias Mann at the Max Planck Institute in Martinsried near Munich has been working closely with us and with a company called EvoCep, which develops chromatography systems for high throughput studies, to push the sensitivity in this area. And he's going to be presenting his latest, very exciting developments in his talk at HUPO. And his student, Andreas Brunner, will be speaking at our post-HUPO users meeting on the topic of single cell proteomics. So I can't say much more about that because that's their work, but it is single cell proteomics. And if you're interested in that field, and a lot of people are, you're definitely going to want to tune into those events.
Right, well, it seems like you've got a lot going on at HUPO actually. And so thank you for covering all of that. There's quite a lot of information there. As Gary says, there's a lot happening at HUPO. There will be links for all of those different topics above the video so that you can register for them. If you want to know more, if they can't make HUPO for whatever reason, where else can they get more information?
Well, we'll include links to our website, which will have information on these various topics. And, from there, if you can't find what you want easily, you can always send an email to our marketing department, and they'll make sure it gets to the right expert to contact you and get you what you need.
Thanks very much. Well, Gary, thank you very much for that. It's lovely to see you again. Now that Prague is in autumn, so maybe next time I'll see you, it's in winter, and then we can go through all the seasons actually and find out what's it like in Prague during those particular seasons.
We're locking down again, as you probably know. So it's a lockdown in autumn in Prague. So
yeah, well, the UK's going that way as well, actually, unfortunately. So it's the way of the world at the moment, isn't it? You lock down, pre-lockdown, then you're all out again, and you lock down again. But never mind. Well, thank you very much for your time. I really appreciate it, Gary. I know you're a very busy man, so thanks for taking the time to have a chat with me. I hope everyone found that useful. As always, check out the links above the video. If you've got any comments, put them below the video, and all that stuff. And says, Gary, as always, thank you very much. Look after yourself, and I'll see you soon.
Thanks, Riz. Bye.
And thank you all for watching. As always, stay well and stay safe. Thanks a lot. Bye-bye.